We continue Unit 14, Direct and Indirect Variation. This is flap 4 and 5 in our foldable. A direct variation is a relationship between two variables x and y. They can be written in the form of y equals k times x. Indirect or inverse variation, y equals k over x, is another type of variation that describes a situation in which one quantity increases and the other decreases. K is the constant of variation. K is not equal to 0. If y varies directly as x and y is equal to 25 when x is equal to 15, find x when y is equal to 40. We have to set up two different equations to solve. We're talking about varies directly. That's the key to which equation to use. Varies directly is y equals k times x. Substitute what we know on the left side. We know that y is 25 and x is 15. So we need to find the constant of variation so that we can figure out what this other equation is. Dividing both sides by 15 gives us 5 over 3. Now we're going to use the other side to find x when y is 40, now that we have that constant of variation k. So substituting k into k, 5/3 into k, and substituting what we know about the second equation, that y is equal to 40, we can find x. Multiply both sides by the reciprocal of 5 over 3, which is 3/5, will get rid of the fraction, or eliminate the number in front of x. This will make this side equal to 1. 40 times 3 is 120, divided by 5. So x is equal to 24. In example 2, if the y varies inversely as x and y equals 22 when x is 6, find x when y is 15. The key word here is varies inversely, so we will write y equals k over x twice and fill out the information on the first side and find k. There is an understood 1 in front of this k, so I really have 22 is equal to 1 over 6 times k. To get rid of that fraction, I need to multiply both sides by the reciprocal 6 over 1. This will cause this side to cancel, leaving 1k equals 132. Now that I know that the constant of variation is 132, plug it back into k on the other side. Also plug in the value 15 for y, since we know that. But I have x in the denominator, so I'm going to use the same trick I used over here. If this is 1 over x, then I'm going to multiply both sides by x over 1. And this will eliminate my x on the right side. On the left side, I have 15x equals 132. Divide both sides by 15 to get x equals 8.8. Example 3. If y varies directly as x and y is equal to 12 when x is equal to 16, find x when y is equal to 36. Again, our key words here are varies directly. So we want to write down the equation y equals kx twice. On the left side, fill in what we know. We know y is 12 and x is 16. What we need to find is our constant of variation so that we can plug it in on this side and solve for x. Divide both sides by 16 gives us k equals 3/4. Now we plug 3/4 into k. And we also plug 36 in for y. And again, I have this tricky number in front of x, and all I have to do is multiply both sides by the reciprocal to get rid of it. Multiply both sides by 4 over 3 will give me x equals 48. To do this, I've simplified. 3 goes into 3 one time, 3 goes into 36 12, and then I can multiply across my fraction. 4 times 12 is 48. When a quantity varies directly as the product of two or more quantities, the variation is called joint variation. In example 4, R varies jointly as S and T and inversely as U. R is equal to 18 when S is 2 and T is 3 and U is 4. We want to find S when R is equal to 6, T is equal to 2, and U is equal to 4. Varies jointly tells us that I'm going to have R equals K times S times T. Varies jointly, think of that as like our equal sign. Remember, varies jointly is a product of S and T. So we have R equals K times S times T. The other thing is it's and inversely as U. So that is divided by U. So we have a compound variation here. Write this down twice. On the first side, R is 18, we don't know K, S is 2, T is 3, and U is 4. Clean this up a bit and we have 18 equals 6K divided by 4. Using the little trick, whatever's in front of the variable we're solving, we can multiply by its reciprocal to eliminate that number. On the left side, since this is 46 times 18 over 1, I can simplify and reduce. 6 goes into 6 one time and into 18 3. And then I can multiply across to get 12. 4 times 3 is 12. Now that I know K is 12, I'm going to plug it into this equation and substitute these variables for their respective numbers to get 6 equals 12 times S times 2 divided by 4. We need to find S. Simplifying, we get 6 equals 24 divided by 4 times S. Well, 24 divided by 4 is 6, and that leaves us 6 equals 6S. Dividing by 6 gives us S equals 1, and that is what we're trying to solve for. Example 5. If x varies jointly as y and z squared, and x equals 100, when y equals 2 and z equals 5, find x when y equals 4 and z equals 3. Varies jointly is our key word here. So that tells us we're going to use x equals the y and the z get multiplied together, or y and z squared get multiplied together with our k, our constant of variation. So we have our formula x equals k y z squared. We write that twice. On the left side, go ahead and fill in what we know. 100 is equal to k, y is equal to 2, and z is equal to 5. Simplifying, get 100 equals k times 50. Divide by 50, and k is equal to 2. Now substitute 2 in for k on the other side. We're looking for x, and we know that k is 2, y is 4, and z is 3. Simplifying, we get x is equal to 8 times 9. So x is equal to 72. Now we're going to look at some applications. We can use variation functions to determine how many people are needed to complete a task, such as building a home in a given time. Some other examples of quantities that vary directly or indirectly are like the number of songs downloaded and the total cost of songs, or the number of workers and time needed to build a highway. Let's look at some applications, somewhere where variation might be used. In example 1, the amount of chlorine needed varies directly as the size of the swimming pool. If 5 units of chlorine is the amount needed for 550 gallons of water, find the amount needed for 850 gallons of water. What are my key words here? Varies directly tells me that I'm going to have a y equals k times x type of situation. But I don't have y and k times x in this problem. So I need to figure out what are my variables. Where do I need to put them? The amount of chlorine needed varies directly. So this is like my y. So chlorine, C is equal to chlorine. Varies directly, there's my equals, as the size of the swimming pool. So that is my x right here, the size of the swimming pool. K is my constant of variation. So my formula is C equals K times S. So write this down twice. Now we just need to fill in the blanks. We know that the units of chlorine are 5 and the gallons needed are 550. What we don't know is our constant of variation. So we need to solve for K. Dividing both sides by 550 gives us K is equal to 1 over 110. Plug this back into K in the other equation. Also plug in what we know. We know we have 850 gallons of water. We're looking for our number of units. Multiply those together and we get 7.7 units. Look at another example. The time required to travel a given distance varies inversely as the speed of travel. If a trip can be made in 3.6 hours at a speed of 70 kilometers per hour, how long will it take to make the same trip at 90 kilometers per hour? We know our key word here, varies inversely, tells us that I'm going to be using something y equals k over x. So we just need to fill in the rest of our pieces of our puzzle. The time, t, required to travel a given distance varies inversely as. So t equals the speed of travel, that's k divided by s. So our speed of travel is going to take the place of the x. T is equal to time and s is equal to speed. Those are our unknowns. If a trip can be made in 3.6 hours at a speed of 70, those are our knowns, so let's plug that into the first expression. 3.6 is our time, k we do not know, and 70 is our speed, miles per hour, or kilometers per hour. Using the little trick I told you, this is really 1 over 70, so I'm going to multiply both sides by 70 over 1. This will eliminate the 70s on this side in front of k. And on this side, 70 times 3.6 equals 252. Now we know k, our constant of variation, so let's plug it into the right equation. We need to know the time it's going to take to make the same trip at 90 kilometers per hour. So filling in 90 for our new speed, we get 252 divided by 90 is 2.8 hours. Remember, this is a word problem, so we have a word answer. Example 3. The power in watts of an electrical current varies jointly as the resistance and the square of the current. For a 600 watt microwave oven that draws a current of 5 amps, the resistance is 24 ohms. What is the resistance of a 200 watt refrigerator that draws a current of 1.7 amps? Our key word here is varies jointly. So we know we're going to be using something to the effect of y equals k times x times z. So we need to figure out our pairs. The power in watts of an electric current, power being P, varies jointly, so there's my equal sign, as the resistance R and the square of the current, C squared. So there is my equation. I'm going to write that down twice and also write down my unknowns. P equals power in watts, R equals resistance in ohms, and C equals the current in amps. Filling in our unknowns on the left, we get 600 is equal to K times 24 times 5 squared. This gives us K is equal to 1. Substitute this back into the right equation with the other things we know. 200 is equal to 1 times R times 1.7 squared. Simplifying, we get R is equal to 69.2 ohms.